Have you ever wondered why data science is so important in today's world? As we dive into the 21st century, data science has become a cornerstone of our society. It has infiltrated all sectors, from healthcare to entertainment, finance to agriculture and beyond. Data science, in essence, is the art and science of turning raw data into actionable insights. Thank you for joining us here at Innovative Muse, where we explore the wonders of technology as it meets innovation. Welcome in. Through data-driven decision-making, businesses can improve their outcomes significantly. They can tailor their services to meet customer needs, optimize their operations, and even predict future trends to stay ahead of the curve. Consider this. Every time you browse online, you leave a data trail. Data scientists use this trail to understand consumer behavior, preferences, and patterns. This knowledge can then be harnessed to enhance user experience, streamline operations, and boost profitability. As we progress, the significance of data science is only set to increase. Let us delve deeper into the key components of data science to understand its significance better. Data science is a broad field, but there are four key components that form its backbone. First up, we have data collection. As the name suggests, this is all about gathering information. But it's not as simple as just picking up facts and figures. It's about identifying the right sources, understanding what data is relevant, and then systematically collecting it. This sets the stage for everything that follows. Next, we have data cleaning. This is where we roll up our sleeves and get our hands dirty. In this stage, we sift through the collected data, correcting errors, dealing with missing values, and removing any inconsistencies. It's a bit like spring cleaning your house, but for data. The cleaner the data, the more reliable the results. The third component is data analysis. Think of this as the detective work of data science. It involves inspecting, transforming, and modeling the data with the goal of discovering useful information. It's about finding patterns, establishing relationships, and deriving insights that can aid in decision-making. Finally, we have machine learning. This is where we allow computers to learn from the data without explicit programming. It's about creating algorithms that can predict outcomes and make decisions based on patterns in the data. Each of these components plays a crucial role in turning raw data into meaningful insights. From collection to cleaning, from analysis to learning, each step builds on the last, transforming data into a powerful tool for understanding and shaping our world. Data science incorporates a variety of techniques to analyze and interpret data. These techniques are the tools that allow data scientists to transform raw data into valuable insights, guiding critical decision-making processes in businesses, governments, and institutions worldwide. First off, we have descriptive statistics. This is the foundation of any data analysis, providing a simple summary of the data at hand. It's like taking a snapshot of data, capturing its key features through measures such as mean, median, mode, and standard deviation. Next up, inferential statistics. This technique takes descriptive statistics a step further, making predictions or inferences about a larger population based on a sample of data. Think of it as being a detective piecing together information from a smaller group to draw conclusions about the larger whole. The third technique is exploratory data analysis, or EDA for short. This is the process of visualizing and analyzing data to extract significant patterns and trends. It's like being an explorer, navigating through the wilderness of data to discover hidden treasures of information. Moving on, we have feature engineering. This technique involves creating new features or modifying existing ones to improve the performance of machine learning models. Consider it as an architect designing and building features that make the data more understandable for the models. Predictive modeling is another essential technique. It uses statistical methods to predict future outcomes based on historical data. It's like having a crystal ball that can forecast what might happen next in your data. Then there's natural language processing, or NLP. This technique helps computers understand, interpret, and manipulate human language, enabling them to interact with text data as humans would. Lastly, we have time series analysis, a technique that deals with data points collected over time. It's like a time traveler, analyzing past trends to forecast future ones. Mastering these techniques is integral to becoming a proficient data scientist. Each technique is like a piece of a puzzle, and together they provide a comprehensive picture of what data science is all about. Implementing data science techniques effectively requires adherence to certain best practices. Firstly, defining clear objectives is pivotal. A successful data science project begins with a well-articulated goal. This serves as a roadmap, guiding your project towards meaningful outcomes. Without a clear objective, you risk wandering aimlessly in the vast landscape of data, wasting time and resources. Next, understanding the data is fundamental. This is more than just knowing what the data represents. It's about appreciating the underlying patterns, anomalies, and connections. Understanding the data lets you ask the right questions and make informed decisions. It's like getting to know a new friend. The more you understand about them, the better your relationship will be. Thirdly, taking an iterative approach is crucial. Data science isn't a linear process. It's a cycle of questioning, exploring, modeling, and learning. Each iteration brings you closer to the truth, refining your understanding and improving your models. It's similar to sculpting, where each stroke reveals more of the masterpiece hidden in the raw material. Focusing on interpretability is also vital. A model that no one understands is of little value, no matter how accurate it is. Strive for models that are both accurate and interpretable to provide insights that are actionable and reliable. Remember, data science is not just about creating complex models, it's about simplifying complexity to make better decisions. Lastly, collaboration is key. Data science is a team sport. It involves statisticians, programmers, domain experts, and decision-makers all working together. Each brings unique skills and perspectives, enriching the project. By collaborating effectively, you can leverage the collective intelligence of your team to achieve more than any individual could alone. So in essence, the best practices in data science revolve around clear objectives, understanding the data, iterative approaches, interpretability, and collaboration. Each contributes in its own way to the success of your data science project. Adhering to these best practices enhances the efficiency and effectiveness of data science applications. To wrap things up, let's summarize what we've discussed today. Data science, a discipline that has become integral to our modern world, offers a robust approach to turning complex data into understandable, actionable insights. It's a blend of various fields, but at its core, it involves four key components: data collection, data cleaning, data analysis, and machine learning. We've delved into the fundamental techniques used in data science, each with its unique role. Descriptive and inferential statistics help us understand and infer trends from data. Exploratory data analysis, or EDA, aids in making sense of data structures, while feature engineering and predictive modeling are used to create predictive models. Natural language processing, or NLP, helps machines understand human language, and time series analysis allows us to analyze data that's sequenced over time. We've also touched on the best practices in data science, which include defining clear objectives, understanding the data, adopting an iterative approach, emphasizing interpretability, and fostering collaboration. These practices can help any data scientist operate more effectively and deliver more accurate results. Data science is more than just a set of techniques and practices. It's a driving force for business growth and innovation. It allows us to see patterns, predict trends, and make strategic decisions based on data. Remember, the power of data science lies in its ability to transform raw data into actionable insights. It's a field that's only going to grow in importance, so understanding it can give you a significant advantage in today's data-driven world. If you found any of this information helpful, please like, comment, share, and subscribe for more. Until next time, be well.